In the fifth unit, we're going to see the topic on IPv4 and IPv6 connecting. Okay, so there is Internet Protocol, which is layer 3 protocol, which is the Internet Protocol belong to the network layer. Okay, so we are going to see the two versions associated with this Internet Protocol. The first version is version 4 and the second version is version 6. Okay. Coming on to the addressing concept, we need to know about the subnetting concept in IP addressing. Okay. So the objective of this session is to make you known about the IPv4, then IPv6 and subnetting concepts. And the outcome of the session is going to be the students will be able to understand the concepts behind IPv4, IPv6 and subnet. And these are the outlines for today's session. So first we'll be knowing about what is meant by Internet Protocol and what is the header format for the Internet Protocol package. Okay. And we'll see how it can be executed in a Windows. That example of IP header can be seen, and the checksum, header checksum, will be seeing how to calculate the checksum for the Internet Protocol. Okay. Then we'll be going on seeing with the IP addressing. What are the classes, types of classes involved in IP address in IPv4. Okay. So coming on the next one, we can go for the subnet addressing. So what is the need to have a subnet mask and what is the purpose of using subnet addressing and what is meant by a CIDR, that is classless inter-domain routing, CIDR. And we'll be seeing, we'll be more concentrating on the IP addressing concepts, in that how to convert a binary number representation into a decimal number and decimal number represented into a binary number. Suppose if the IP address is given in binary number, then how to convert? Yes, ma'am? Okay. Okay, ma'am. Let me raise my voice. Okay. Thank you, ma'am. So if you are given an IP address, then we'll be seeing how to convert the IP address that is represented in binary number into a decimal number. As well as if you are given an IP address in decimal number format, then we'll be seeing how to convert from decimal number into a binary number. Okay. Then we'll move on to the subnetting concept and what is the secret concept behind subnet mask. Okay, so this is what the plan for today's session. So next we'll move on to the introduction of Internet Protocol. Okay, so Internet Protocol is a layer 3 protocol, which is layer 3 means it's a network protocol. So in the network layer, you can go by using Internet Protocol, ICMP, that is Internet Control Message Protocol, then IGMP, that is Internet Group Management Protocol. So these three types of protocol can be used at the network layer. Okay. As similar in the earlier classes, we have seen TCP and UDP as a transport layer protocol. Likewise, IP, that is Internet Protocol, ICMP, IGMP. So these three are called as network layer protocol. So similar to the UDP protocol, as we have seen, the same thing is also serviced by the Internet Protocol also. So Internet Protocol is also called as, or it provides the best effort delivery, and it is also connectionless packet delivery protocol. Okay, so these two services are provided by Internet Protocol. Okay, and also if you are using Internet Protocol, the packet may be lost on it, or it may get out of order at the destination point, or it may be even duplicated. Okay, at the destination point in between the transmission. The packets may get duplicated also. So all these can occur with the usage of internet protocol. Okay. So also the higher layer protocols. What are the higher layer protocols of network layer? That is transport layer is there. TCP UDP will also be using this internet protocol. Okay. So what is this ICMP and IGMP? All these protocols are used at the network layer. So ICMP means Internet Control Message Protocol, and this is a error reporting protocol. So where we will use this ICMP protocol means whenever the error occurs during the transmission of the packet, then we will be using this ICMP protocol, which we call it as a error reporting protocol, that it will be used by the networking devices such as routers. So routers will be using this ICMP protocol to generate the error messages, and they will report to the source with the help of the source IP address. Whenever the network problem occurs, it will report to the error messages to the source address. So that is the functionality of ICMP, Internet Control Message Protocol. So it's an error called as error reporting protocol. Okay. So coming on to the Internet Group Management Protocol, that is IGMP. It is a common protocol used by the host machine and the adjacent routers. So mainly this will be used by the IPv4 version 4. Will be using this IGMP to establish the multicasting communications. In order to establish a multicasting communication, IGMP protocol is used. Okay. So coming on to the packet format, header packet format for the internet protocol. So this is this you can see it's a 32-bit internet protocol. Okay, starting from 0 to 31. It occupies 4 bytes for the version field. So totally it may be consisting of minimum 20 bytes header, okay, and up to 40 bytes in the option fields. Okay, so you can see here option field. So for that option field, it can go out to contain 40 bytes. So the maximum length it can have 60 bytes. Okay. Okay. So now you are seeing the version, current IP version is 4. Okay. And IHL means, second field is IHL, that is Internet Header Length. So this is specifying the length of the header in 32-bit words. Okay. And coming on to the next is type of service, which is the 8-bit word. It is usually specifying the priority of packet at each router. And it also specifies differentiated services is used. It redefines the type of service field to include the other services beside the best effort. Okay. So why we are using the type of service field means, so the packet can be given priority, okay, at the time of the transmission of the from one host to another host or one device to another device. Okay, it can also have the differentiated service also. Okay, the next field is total length. So total length is specifying the number of bytes that IP packet which contains both the header as well as the data. And the maximum length it can hold up to 65,535 bytes of total IP can be. Okay. And the next field is identification field. fragments, fragment offset. So these three fields are used for the fragmentation purpose and reassembly of the packets at the destination point. Okay. So fragmentation means the process of breaking up the packet into so many number of pieces. Okay. And reassembly means, so at the destination, so after reassembling all the fragment pieces of packets, that will be done at the destination point. So for these fragmentation and reassembly, these three fields are used. Okay. The next field is time to live. So time to live is all referring the how long the packet resides or travel inside the network. So the time is mentioned at this time to live field. Okay. Okay. So here, the time to live is shortly represented as TTL. It defines the number of hops. What do you mean by hop? So the transfer of packet, if it traversing from one router to another router or any two connecting devices, that is going to be called as one hop. So time to live will be representing how many number of hops the packet is going to travel inside the network. So that count of the hop count is specified in this time to live field. Okay. Next, protocol. So protocol field is will be specifying the upper layer protocol, that is to receive the IP data at the destination. For example, if the upper layer protocol is TCP, so for that the value mentioned is 6. And or else if the upper layer protocol UDP is used, means for that protocol value 17 is to be mentioned here. Okay. And if it is ICMP, the protocol value will be 1. So for the upper layer protocols, some values, the protocol values are mentioned in this protocol field. Okay. So protocol field specifies the upper layer protocol. Okay. And coming on to the header checksum field, it verifies the correctness of the IP header. Okay. So the thing is that it will identify whether any error has occurred or not. So for that purpose, we are having the header checksum field. Okay. Coming on to the next, source IP address and destination IP address, all these are 32 bits, which will be containing the address of the source IP and the address of the destination host. Okay. The next field is option. So option is a variable length field. Okay. It allows the packets to request any special features such as security level or the route. So what is the route to be taken by the packet, or timestamp at each router. So all these special features we can go for using option field. Okay. And coming on to the next, padding field. So this field is used to make header a multiple of 32 bit words. Padding means you are going to add some more bits onto it. Okay. Okay. So this differentiated service is related with the type of service. As we have seen in the previous slide, type of service is associated with the differentiated service. It's the 8 bits to provide the quality of service to the packets. So which depends upon the traffic type. Okay. So out of 8 bits, the leftmost 6 bit is or used as code point. That is called as DSCP. So DSCP means differentiated service code point CP. Okay. This will select in order to select the per hop behavior. PHB means per hop behavior, a packet experience at each node. Okay. And the routers will be examining this differentiated service field, and it will provide an S3 treatment to the packet. And the remaining last two bits on the right side, they are called as ession field. Ession means explicit congestion notification. For example, consider if the congestion occurs. Congestion means traffic occurs while transmitting the packet. If it is so, then the type of service, differentiated service will come into picture. Okay. So in that case, explicit congestion notification field. Okay. So it is going to represent these two bits. That is, it is represented by 2 bits. If 00 means represents that non-ession capable transport. Okay, and 10 representing ession capable, that is capable transport, and 01 representing ECT1. Okay, and 11 representing congestion encounter. Okay, so all these. So 11 is representing the congestion has been occurred. It is specifying that. Okay. So this ECT of 0, ECT of 1. So these two bits will be used by the data sender. When the router, any router notifies or it faces any network problem, network congestion, if it detects congestion, then it will set the ECN bits to 11. It shows that some problem has been occurred or traffic has been occurred. That will intimate to the receiver to know about the congestion. So that will be done by the differentiated service in the type of service field. Okay. So next, identification is a 16-bit field used to identify the fragments of one packet datagram from those of the another. Okay. And coming on to the flag fields, there are 3 bits are represented: bit 0, bit 1, and bit 2. So bit 0 is representing research. It's mainly meant for research. Okay, and it must be set to 0. And bit 1 is representing don't fragment, that is DF. It is represented as DF. So don't fragment means it should not go by breaking the packets. And bit 2 is representing more fragments, MF. Okay. And coming on to the fragment offset, it occupies 13 bits. So usually this fragment offset will be used at the time of the reassembly of the fragmented packets at the destination point. So this value will be directing to obtain the chunk. Chunk means some piece of fragments. Chunk means it's a group of fragmented packets that is called as a chunk. Okay, in the first fragment offset is 0. And in the last fragment, MF means more fragment. It represents more fragments of there. And coming on to the options field in IP header, I think the screen is not visible, I think so. Okay, so option field can go up to 40 bytes. Okay. So the option field allows the packet to request some more features. Some of the options are security options, record route, source route, timestamp, loose source route. Can I have response that the screen is visible?
Ma'am, your presentation screen is visible, ma'am.
Okay, thank you, ma'am. Okay, so security, coming on to the security option, the routers will be going on avoiding the path. Is there any condition occurs? Yes.
Sorry for the interruption, ma'am. Ma'am, it is not visible, ma'am. I mean, you are not presenting the screen, ma'am.
Yes. Let me go on present once again. Check whether is it visible. It's coming out.
Again, it comes not presented, ma'am.
Yes, yes, okay. I think now it's okay. Is it visible?
Yes, ma'am. Visible, ma'am. Visible,
Okay.
ma'am.
Okay. Okay. So option area is goes up to 40 bytes. There are so many options are there. So the options may be used for security purpose, or it can be used for record root. So source root, loose source root, timestamp. Okay. So all these are the options which can be used in the IP header format. Okay. So this is an example of the how the IP header packets will be showing. So as we have seen the format, the first will be representing the version. So it is representing 4. So it means that version IPv4 is used here, and header length is mentioned 20 bytes. Okay, and differentiated field is seeded DSCP 0xx and default ECN is 00. Okay, and the total length of the IP header is 48 is mentioned. Okay, so as we have seen, the maximum length it can hold is up to 60 bytes. Okay, and identification field is having some values. Flag is also having some values. 1 is representing don't fragment and 0 is representing don't fragment. So don't fragment is set here. Okay. And 0 means it is more fragment is not set. And the fragment offset is also set 0. And time to live means 128 is representing the number of hops. Of count is 128. So then protocol used, higher level protocol is TCP is used. Header checksum value is stating that correct. Okay. And source IP address is given, destination IP address is given, and last thing it is given the source port address, destination port address, and the sequence number. Okay. So this will be the format or the values entered in the IP header. So one such example is depicted here. Okay. So coming on to the checksum part, usually checksum in the header field, header format used to error detection. Okay. So IP header will be using this check bit to detect the errors in the header. So it is calculated for the header content. Checksum is also recalculated at every router. So whenever the packet comes or reaches the router, checksum will do the error detection. Okay. So it is 16-bit words starting from B0 goes on up to BL-1. So the algorithm used is the 16-bit checksum, which is represented by DL. So BL checksum can be calculated using the formula here. So BL is checksum that is minus S modulo of 2 power 15 minus 1. So since checksum is a 16-bit field, so this is the 16-bit ones complement of the sum of these. As we have discussed in the earlier class, how the checksum is calculated. So we need to go with the binary format for each and every IP address. We need to convert into binary representation, and we have to go represent in the binary representation for all the fields. Then you have to go for calculating the sum of all the IP. That is whatever the values given in the field, each and every field, we have to go by calculating the sum. After that, we have to give the ones complement of the sum. That is going to be a checksum. Okay. That is represented here. See here, ones complement of the sum of the D. That is your checksum value. Okay. So the header processing, how it process, it is depicted in 3 steps. First, it will compute the header checksum for the correctness and check the fields in the header. That is, it will be go by checking with the version and total length, whether it is containing the correct values or not. Okay, so in this way the checksum works. Okay? So for each and every field, the checksum field will go by checking what are the values given in the particular field will be checked with the checksum. That is the purpose of the checksum in the IP header. Okay, and it also consults with the routing table to determine what is the next hop to traverse the packet. Okay. And it will also go by changing the fields that require updating. It can go by changing the TTL time to live field or header checksum field. So in this way, the process of header will go on. So coming on to the IP addressing in IPv4, so each and every host machine will be having an IP address, valid IP address. Okay, so that will be assigned by IANA, that is Internet Assigned Number Authority, so which will be responsible for allocating the blocks of addresses to the Internet Service Provider. So don't forget, make the note that IANA will be going to assign the addresses to the Internet Service Provider. Okay, and this IANA will be operated by ICANN, that is ICANN, Internet Corporation for Assigned Names and Numbers. Okay, so moreover, this IP address can be a static address or dynamic address. So the host, if it is said to be a multi-home, then it can have some multiple IP addresses also. So normally IP address will be consisting of 2 parts. One is the network part and the host part. Okay. So here you can see clearly in the picture that is an internet address or IP address is made up of 4 bytes. So that is totally it occupies 32-bit IP address. We'll be saying like this: 32-bit IP address, which defines host connection to a network. Okay. So in this, the first part is going to be specifying your network part, network portion, net ID, and the second part is going to specify the host machine, host ID. Okay. So as we have seen, IP address version 4 is a 32-bit IP address. Okay, and this address is going to have 2 portions: network portion and host portion. Network portion is called as net ID, and the host portion is called as host ID. Okay, so the 32-bit of IPv4 address are divided into 4 bytes, which is separated by dots. Either it can be written in binary or it can be written in equivalent decimal for each byte. Okay. For example, I can say 192.13.32.24, which is represented in a decimal format, and these are the representations. Zeros and ones are represented in the binary format. Okay. So each byte. So you can see 4. That is 4 bytes. So IP address can be represented in 4 bytes. Okay. Each byte is represented by a dot, and each byte may take the value up to 0 to 255. It means that, so here in the first byte you can see 192. That is, in the first byte it can range up to 0 value to 255, and in the second byte also from 0 to 255. So each and every dot, that is value, will be ranging from 0 to 255. Okay. Okay. So internet IP address are divided into 5 classes. So out of 5 classes, the 3 classes are mostly used. So 3 classes are significant for unicast addressing. And this addressing mechanism is called as classful addressing. Okay, classful addressing. So So out of 5 classes, D and E are D class is used for multicast purpose and E class is used for research purpose, okay, for future use. Okay, always as we have seen, IP address is consisting of 4 bytes and each byte will be ranges from 0 to 255. Okay, so always the first part is going to be representing the network part and the second part is going to represent the host part. Okay, for class A, always in the network portion, the first bit will be representing the value 0. It is a constant value. And for class B, it always starts with the 10. And for class C, it always starts with 110. And for class D, 1110. And for class E, 41. Okay, make a note of it. Okay. So the same thing is depicted here. Okay. So class A will be occupying only 1 byte of network portion, and the remaining all 3 bytes will be of host portion. Okay. And for class B, getting again. Okay, let me continue here. For class B, it occupies 2 bytes of network portion and 2 bytes of, that is 3 and 4 is representing the host portion. And for class C, 3 bytes are occupying the portion and the last byte is occupying the host portion. Okay. And coming on to the reserved host. The host will be for booting up process. So in that, reserved all will be represented as 0. Okay. And if you are using a broadcast ID, and all the host ID will be set as 1. So this represents 1 represent on the host ID representing the broadcast on the local network. Okay. So if it is broadcast on the distant network means it will be showing like this representation of 1 in the host portion. Okay. Okay. So address 0.0.0.0 is allocated for booting purpose. Booting, or we can say initialization phase. And the network ID 0 refers to network identification, and that is network ID dot 0 representing the network identification, and 0 dot host ID representing the host on the local network. Okay, and one more important point, that the address between 127.0.0.1 it goes up to 127.0.0.254 is called as loopback address. Whenever this address is used for testing purpose. Okay, 127 is used for loopback. It is called as loop address and it's used for testing purpose. If the address, as already we have seen, all ones means all 255 in each and every 4 bytes. Okay. If it is so, then it means broadcast in the local network. It does not mean that it is not a broadcast in the entire internet. It is broadcast in the local network. Okay. So you can see the 5 different classes of IPv4 addresses. Now, in the following slides, we are going to get how we are going to get this tabulation. Okay, we'll see this. Okay. So as IPv4 version 4 address is the 32-bit log, and it can be a string. If you are going to represent in binary format, it will be represented as zeros and ones. All the 4 bytes will be, each byte will be having 8 bits, zeros and ones. Okay, so total you will be having 32 bits of zeros and ones. Okay. In other words, we can can say like IP address will be consisting of 4 octets or 4 8 bits of zeros and ones. So each is represented by dots. And if you are coming to saying with the zeros and ones, each octet will be ranging from 8 zeros and 8 ones. Okay. So coming on to the decimal representation, it consists of 4 decimal numbers separated by dots. For example, 192.168.4.2. And each and every octet, that is each and every value in the dots, will be the number ranges from 0 and 255. Okay. So now we are going to see how we are going to fill all the values in these tables. That's the task. Okay. So as class A, here you can always the decimal representation values will be ranging from 0 to 255. Okay. So the class A will be starting from this you can start the decimal range 0. And the class E, the last value is, you can see from here, the last value is 255. So it is represented here. Okay. And what is the range of the class B? See? So this we call this 1, 2, 4, 8, 16, 32, 64 and 128. This is, we call it as a table used for converting the IP address from binary to decimal and decimal to binary. Okay, fine. Okay. So let's start with the left side. Okay, left side what you are having? 128. So 128 followed by 64 is added, we get 192. Okay. So in this picture, last thing, 0 to 128. So in between, the range can be specified 0 to 127 as the first range. And class B, it starts with the value 128. It goes up to 191. And C class range starts with 192. Okay. See here. So whatever values, you can add up all these things, and you can have the values here. Okay. 224. Next thing, we will be getting 224 starting value for D. Then to get starting value for class E, you can add 128 plus 64 plus 32 plus 15. You will be getting 240. So 240 can be entered here. Okay. So all the values are entered here. So coming on to the first octet binary range, as already we have seen. So always the class A should start with a 0, and class B starts with 10, class C 110, and class D 1110. So that will be filled in this first octet binary range. So next thing, you have to go for the IP range. So how will you represent? Okay. So this is 0 to 127. So you have to represent Okay, so coming for the class A, suppose if you're taking 127, it is represented as the first value will be always 0 for the class A, and it is represented in the binary ones. Okay, so calculate the number of zeros in the network part. So here you can have 24 zeros. Okay, so we can have the calculate the host is 2 power 24 minus 2. Okay, so see here the subnet mask for the class A is the class, that is only the network portion will be 1. Okay, 255. So okay, so 255 is represented all ones here. Okay, and remaining all zeros in the decimal part, it is represented 24 zeros. Okay, so we are taking 2 power 24. Okay, coming on to the class B, you can have 2 octets, that is 16 bits will be 1. Okay, see the 16 bits represented 255.255 means it is represented 16 bits 1, and the remaining 2 network part zeros in all 16 bits 0 is represented. So now calculating the number of zeros, you will be having 16 number of zeros. So you can go for calculating 2 power number of zeros is 16 minus 2. Okay, and coming on to the class C, you can have 24 ones in the subnet mask of class C, and only the last portion, that is 0 is network host portion, that is only 8 zeros. So coming on to count of zeros, it is only having 8. So 2 power 8 minus 2 will be the host per network ID. Okay, so in this manner you have to fill all the values in host per network ID. Coming on to the next to last field, number of networks. How will you calculate the number of networks? So using the formula n is the representing the number of networks, 2 power y. So y is nothing but the number of ones. Okay, so coming on to the class A, you are having only how many ones? 7 ones. Okay, we'll move on to the previous. So here you can see for the subnet mask, you are having only 7 ones. So because the 0 is representing the default value, so leaving that, you'll be having 7. Okay, next 2 power 17, next 2 power 21. Fine. Okay, next we will see private IP address. So here the specific ranges of IP address are set for use in the private networks. So some restricted networks will be using this private IP address. Okay, so not all the users will be go on using this private IP address. Okay, so their use is restricted to use the many users, or some of the users only allowed to use this private address to utilize the private networks. Okay, so okay, so make a note of this NAT, that is network address translation, is used to convert the private IP address and the global IP address. So for the conversion, NET is used, network address translation. Okay. So here you can see two networks which is connected by the router. So each network, the first network is starting with the IP address 128.135.0.0. So can you specify which type of class address is this? That is, it falls on class A, ranges from 0 to 127, and class B 128 to 191. So it falls on class B address. Okay, make a note of that. So you can by using or by seeing the IP address, you can clearly see which type of class address is used. Okay, and okay, so in the first network it is having 3 hosts, and in the second network it's having 2 hosts are connected to it. Okay, so addressed with the host ID, all zeros refers to the network. Okay, and address with the host ID, all ones refers to the broadcast packet. Okay, so what is as we have seen clear earlier, this IP address will be distributed by IANA. Okay, that will be controlled by ICANN. So IANA is address space allocation. Okay, so IANA will be allocating the IP address blocks to the regional internet registries. So this regional internet registries allocate the public internet address space within their regions. So there are 5 regions are available in the world. That is, African NIC is African Network Information Center, Asia Pacific Network Information Center, and American Registry for Internet Numbers, then Latin American and Caribbean IP address regional registry, and RIPE NCC. Okay. Next, coming on to the subnet addressing and classless inter-domain routing. So subnet means, what is the need for subnet means, if the network is going to subdivide it further. That is, network is divided into small network. That is called a subnetwork. Subnet, we call that as a subnet. So if a subnet mask is 255.255.255.0, then the ones indicate the subnet portion and the zeros indicate the host portion. Okay. Okay. So this mask is also written like /24. Okay. So how many ones can be there? 24. So IP address is 32 bits. Out of 32, 24 is representing all as ones. So we can represent by /24 is representing the mask. Okay. And CIDR is classless inter-domain routing. Okay. So that subnet may be created using CIDR. So this method of allocating the addresses does not consider the concept of classes. Okay. Okay. So what is the advantage of using CIDR? Mainly CIDR is classless interdomain routing. It's mainly used for finding out the subnetwork. Okay. So what is the advantage of using this CIDR over the classful IP addresses mean? Classful means we are having 5 classes, no? So what is the advantage is that it reduces the size of the routing table entries. Okay, and it can also manage the IP address space more effectively. Okay, so let's move depth into the IP address. It's a numerical value or address is used as an identifier for any host machine or any device on the network. Okay, and every device will be having the IP address for the communication purpose. So if the packet is transmitted from one host to another host, it is for each and every host mission is represented by a IP address. Okay, there will be consisting of two parts. One is the network address and the other one is host address. So how to convert the binary representation of the IP address into the decimal representation of IP address? We'll see how to convert. So as I told, this is the chart or table used to convert the binary to decimal and as well as decimal to binary. Okay. Okay, so if you are given the IP address like this, the below IP address is given here. So the first part, first octet is represented or written below the chart. Okay, so out of this you can take only the ones. Okay, so what is the one is representing 128, 32, 4 and 1. So all these are taking the sum, you will be getting 165. So in this manner you can get the numerical value, that is decimal value for the corresponding binary format. So in this way the other octet also written in the chart and you have to get out the values. Okay, the next number 0 0 1 1 0 1 0. So you have to write according to the numbers in the chart. Okay, so again ignoring the zeros, consider only the ones, you will get the value 58. Okay, and the next octet, third octet going to be performed, ignoring the zeros and calculating the values for 1, you will be getting 199 and the last one 43. So as a result, whenever you are getting a binary values, you can go on to stick on to this table and write the given binary values. Then each and every binary you will be getting a proper decimal number. Okay, this the number represented in binary, it's converted into decimal. Okay, here you are getting the answer. So coming on to the IPv4, there is the current version is 4. So 32-bit address. Then you can represent by 4 octets. So here the given IP address is a decimal values separated by dots. Okay, so each octet is ranging from 0 to 255 as we have already seen. Okay, so there are 4 billion possible unique addresses are there. Okay, so the same thing. So usually the computers and the network don't use the or read the IP address in the numeric format. So only the computer will understand the binary format, that is represented as zeros and ones. Okay, so how will you take this for 66? How you are getting this? You can use those table. See here. So we call this table as a 8-bit octet chart. Okay. So for 66, you can go by representing 1 under the 64 and for 2 under, you can represent 1. So on calculating or make a addition of these two, or make a taking a sum of these two, you will be getting 66. So all others will be 0. You can take that as for the representation of 66. 0 1 4 0s 1 0. Okay, likewise for 94 you can go by entry. 94 you can take 64 as 1 and 16 and 8 and 4 and 2. You'll get 94. For each and every octet you can get out the values in this manner. Okay, and for 29 the value is calculated and for 13 the value is calculated. Thus for 66.94.29.13 you can get these binary values with the help of this 8-bit octet chart. Okay. Next version is IPv6. So this is the next generation of the IP addresses. So it will be having 128-bit hexadecimal address. So coming on to the IPv4, you'll be having 32-bit address. Okay, and IPv6 is 128 hexadecimal address. Okay, So it will be using both the numbers and the alphabets. Okay. So it is capable of producing over 340 undecillion addresses. So for this, you can for the binary to decimal, you can have the 4-bit chart. As in IPv4, we can take the 8-bit chart, 8-bit octet chart. Likewise, you can use the 4-bit chart in the IPv6. Okay, so 8421. So we can see this all or the addition of the previous one. So 1 added with the 1, you will be getting 2. 2 added with 2, you will be getting 4, and 4 added with so screen is visible. Can I have any response? Okay, ma. Okay. So as 13 cannot be written as double digit in the 4-bit representation, you have to go with this 10 is represented as A alphabetical character and 11 is represented as B. Likewise, up to 15, you have to use the alphabetical values. Okay. So for 13, you have to represent D. Sorry. Okay. So for the first 8, sorry, 26 dB is written. First octet, it is completed. Okay. Likewise, you have to go by completing 128 bits in IPv6 address. Okay. Next, we'll come on to the subnetting concept. As I told, a subnet means that is the network is going to divide into further subnetworks. Divide into again small network, that is called a subnet. Okay. So subnet is logical subdivision of the IP network. Okay. The process of dividing the network into two or more another networks is called a subnetting. Okay. So we'll see one example. So here you can have the subnet 1, 2 goes on up to 256. Okay. There are 8 numbers here. Okay. And the host is represented the reverse of the subnet row. Okay. It's the host starts with 256, 120, the reverse of the first row. Okay. And you can say that each and every number is half of the previous number. Okay. So if you are taking 128 is the half of the previous number 256. If you are taking 64 is the half of the 128. 32 is the half of the 64. Likewise. Okay. The third row is the subnet mask. We can use the shortened format for the first subnet. You can use subnet mask as /24. It goes up to, I think the screen is not visible. Yes. Let me go on once again. Now check whether your the screen is visible.
Yes, ma'am.
Okay, ma. Thank you. You can go by representing the /24 subnet mask as /24 /25 goes on at the 32. Okay. So this we call it as a subnetting table. Okay. In case, so you have to use the subnet table. Consider that. Okay, you are given a network ID 192.168.4.0/24. Okay, so the problem is you have to go for 3 subnets. So check whether you're required to get 3 subnets. So in the first row, subnet row, check whether 3 is available. So no such 3 is available in the first row. So you have to go with